Hi, this is problem number 9 on moment of inertia. Here it is asked to find moment of inertia of the area. Okay, means we have to find Ixx and Iyy. Moment of inertia about x-axis and the y-axis. Okay, so this problem is a kind of a tricky problem. Okay, so listen carefully. Now let us begin with drawing the reference axis. This is reference 1 axis. This is reference 1 axis and reference 2 axis. Reference axis 2. Let me draw the centroidal axis also, about which we have to find the moment of inertia. This is centroidal x-axis. This is centroidal y-axis. Centroidal y-axis. Okay. See, if you check the symmetry of the figure is symmetric about x-axis and symmetric about y-axis. Okay. And apart from symmetry about x-axis and y-axis, you should check the symmetry of centroidal axis of the main figure and centroidal axis of the individual figures. Okay, this I have already explained in the one of the videos in the beginning of this moment of inertia. Okay, what I will do is I will draw. Now I have drawn centroidal axis for the whole figure. Now I will draw centroidal axis for the individual figures. Okay, individual figures means there are 3 components here in this figure. One is rectangle and one semicircle, another semicircle, 2 semicircles and 1 rectangle is there. Total 3 components are there. For all the 3 components I will draw the reference, means centroidal axis. Okay, I am drawing the, now I have already drawn centroidal axis of the whole figure. Now I am drawing centroidal axis of the individual figures. See, for, let me call this as semicircle number 1. Okay, or let me take this total rectangle as component number 1. Component number 1. See, we have to find the moment of inertia of the shaded portion only. In the problem it is not mentioned, but shading is given. No, by default it is understood that we have to find the moment of inertia of the shaded portion only. I will take this total rectangle as component number 1, this semicircle as component number 2, and this semicircle as component number 3. Okay. Now I will draw the centroidal axis for component number 2, that is semicircle 2. So this is centroidal x-axis and centroidal y-axis. Okay. Then for the rectangle, here only it will come. So this is centroidal x-axis and centroidal y-axis. For semicircle 3, this is centroidal x-axis and centroidal y-axis. Okay. Now in the figure we can see that centroidal x-axis for the whole figure and centroidal x-axis for the individual figure are same. Okay, centroidal x-axis for the whole figure and centroidal x-axis for the individual figures are same. Therefore, the condition Ixx is equal to sigma Igx is applicable. It holds good. Coming to the y-axis, centroidal y-axis for the whole figure and centroidal y-axis for the individual components. Okay, individual components are not same. They are not same. Okay, they are not laying in the same line. Therefore the condition Iyy is equal to sigma Igi is not applicable. Even though the figure is symmetric about y-axis, the Iyy is equal to sigma Igi is not applicable because centroidal y-axis for the whole figure, centroidal y-axis for the individual components are not coinciding. Okay, they are not laying in the same line. Therefore this Iyy is equal to sigma Igi is not applicable. So we have to find this Iyy by using conventional method, means by using these two formulae. Okay, so I hope you understood. Now what are all the parameters we require? So we have to use these two formulae to find the Iyy. Okay, Iyy. So we have area values, then we have x values, ax is needed, ax square is needed, then Igy is also needed, and we know that Igx is equal to sigma Igx. We should add another column of Igx as well. So these are all the parameters needed. Okay, so here I have written the tabular column including all the parameters. Okay, let me write the units first. Here mm square, millimeter, millimeter cube, millimeter raised to 4, millimeter raised to 4, and millimeter raised to 4. Okay, now we will take the components one by one. First component is total rectangle. Total rectangle component number 1. Area is b into d. Width of the rectangle is 50 and depth is given as 80. 50 by 80. 50 by 80. 4000 mm square. Coming to the x value for rectangle, it is b by 2. Okay, b by 2 means b is 50 divided by 2. You will get 25 mm. Ax, if you calculate, you will get that as 100 into 10 power 3. Ax square, you will get it as 2.5 into 10 power 6. Igx formula, we know that bd cube divided by 12. 50 into 80 cube divided by 12. The answer is 2.133 into 10 power 6. Igy formula is db cube divided by 12. 80 into 50 cube divided by 12. The answer is 833.33 into 10 power 3 into 10 power 3. To this calculation for rectangle is over. Now we will take the second component, semicircle. Semicircle, which is component number 2, and area, very important, negative sign because it is unshaded portion, minus pi r square by 2. Pi r square by 2. The radius of semicircle is 10 mm. Okay, it is given. It is a symmetric figure. Whatever the radius on the right side semicircle we have, it will have the same radius here. Minus pi into 10 square by 2. Answer is 157.07. Minus 157.07. Okay, coming to the x value. X value for semicircle means distance of this centroid. Distance of centroid of semicircle from reference 1 axis. This distance. Okay, distance of centroid from the diameter of the semicircle is always 4r by 3 pi. Correct. For semicircle, distance of centroid from its diameter is always 4r by 3 pi. Here also, if I take G3 as centroid, from the diameter it is 4r by 3 pi. From the diameter, from its diameter, the distance of its centroid is 4r by 3 pi. Okay, so here I'll take 4r by 3 pi, 4 into 10 divided by 3 pi. Answer is 4.244 millimeter. AX value you will get it as minus 666.60. AX square you will get it as minus 2829.0907. Then IGX formula for semicircle. See the alignment of the semicircle. It is vertical alignment. It is having vertical alignment. For vertical alignment, IXX is equal to pi r raised to 4 by 8 and IYY is equal to 0.11 r to the power of 4. So IXX is equal to what is the formula? Pi r raised to 4 by 8, and very important, negative sign, minus pi r raised to 4 by 8, because it is an unshaded portion. Both semicircles are unshaded, so you have to take negative sign while finding IGX and IGY. So here minus pi into 10 to the power of 4 by 8. Answer is minus 3927. Okay. So here IGY formula minus 0.11 r to the power of 4 is equal to minus 0.11 10 to the power of 4. The answer is minus 1100. Okay. Now we will take the third component, semicircle 3. Semicircle 3. Area is same only, minus pi r square by 2. They both are having same radius. You will get the same answer, minus 157.07. Okay. Coming to the x value for semicircle 3. X value for semicircle 3 means it is distance of this G3. Distance of G3 from reference 1 axis. So this distance. Okay. X value for semicircle 3 is distance of G3 from reference reference 2 axis. Reference 2 axis. How you will calculate? See, you know the overall length. It is 50. Overall length is 50. 50 minus 4r by 3 pi will give x value for semicircle 3. Okay. Overall length 50 minus this 4r by 3 pi will give distance of G3 from reference 2 axis, which is x value for semicircle 3. I will write the same calculation here. 50 minus 4r by 3 pi. 4r by 3 pi. Therefore, it is 50 minus 4r by 3 pi value is here 4.244. 244 because radius is same. That's why I am copying the same value. 50 minus 4 you will get 45.75. Okay. So you may get difference in last 1 or 2 digits in your answers. So don't worry. You just go ahead. Okay. Finally, you will get the same answer. Okay. Here AX value is it is minus 7185.95. Then AX square it is minus 328.75 into 10 power 3. Then IGX is same formula, minus pi r raised to 4 by 8, and you will get the same values, minus 3927. Here also same formula, minus 0.11 r to the power of 4. So this semicircle 3 is also having vertical alignment. Okay. Same answer, minus 1100. Okay. Now we will calculate the sum of all the values. Total area it is 3685.86. Sigma AX is equal to 92147.45. Sigma AX square is equal to 2.168 into 10 power 6. Sigma IGX is equal to 2.125 into 10 power 6. Sigma IGY is equal to, it is 831130. Okay. Now we know that IXX is equal to sigma IGX. Directly we will write the answer for IXX first. IXX is equal to sigma IGX is equal to how much it is, 2.125 into 10 power 6 millimeter to the power of 4. So this is the answer for IXX, and we have to calculate IYY by using these two formulae. First formula is I22 is equal to sigma IGY plus sigma AX square. I22 is equal to sigma IGY plus sigma AX square. Sigma IGY is 831130 plus sigma AX square is 2.168 into 10 power 6. Okay. By this we will get moment of inertia about axis 2, that is 2.999 into 10 power 6 millimeter raised to 4. Okay. Now we will take the second formula. I22 is equal to IYY plus AX bar square. I22 is equal to IYY plus A into X bar square. I will rewrite this formula as IYY is equal to I22 minus A into X bar square. We need X bar value here. X bar is equal to sigma AX divided by sigma A. Sigma AX value is 92,147.45 divided by total area is 3685.86. The answer for X bar is 25 mm. 25 mm. Okay. Now substitute in this formula. Therefore IYY is equal to I22. We have got it as 2.999 into 10 power 6 minus capital A means total area 3685.86 into X bar square 25 square. By this we will get moment of inertia about y axis, that is 695.337 into 10 power 3 millimeter raised to 4. Okay. So this completes the solution of this problem. Okay. Thank you.